Hi there, my name's Cam McEwen. Today I'm going to be talking about enterprise security, the missing link, an article that I have published on Medium. This is an introductory article and we're looking at the mechanisms that we use in organisations to defend our core data. Now, this mechanism isn't unlike what used to happen back in the day in ancient times. Architects of cities would protect the core city against attack by building multiple walls. Therefore, when attackers tried to penetrate the core cities, they had a number of obstacles in the way, and alongside those obstacles would be defenders who would defend against attack, and they would stop the attackers actually getting to the core city. Now, this method has been documented as being 100% effective. Therefore, it's not surprising that in our modern day and age, we actually use the same sort of mechanism to defend our core data. When we compare the ancient architecture of having the core town right in the middle and round about it a number of layers of walls to protect it, by looking at the Microsoft architecture diagram, thank you Microsoft, we can see that in a defense in depth architecture, there are multiple layers for an attacker to have to breach in order to try and get at the core asset, that is the data of the organisation. In the way, there are many devices, many applications for that attacker to be able to breach, to actually reach the data. And that is the essence of the defense in depth architecture. Throughout the defense in depth architecture, there are a number of devices which will sit on the layers to attempt to identify anomalous traffic. Devices such as intrusion detection platforms will look for traffic signatures, and devices such as virus scanners will look for known signatures that are understood to be within a library of attacks. So to kind of summarise those two types of approaches, there's a kind of signature-based approach which is useful for understanding and identifying known attacks, which aren't very useful at unknown attacks. So unknown attacks are those attacks which are known as zero-day attacks. Zero-day attacks are not registered anywhere and therefore fall out of the radar of these signature-based approaches. The alternative to signature-based approaches is to use an anomaly detection platform. Anomaly detection platforms use machine learning and algorithms to try and detect unusual behaviour, either at the network level, the user level, or software misbehaviour. Now, anomaly detection is only as useful as how the actual machine learning platforms have been trained themselves. So, for example, we could train an anomaly detection platform at a network level which is already infected with a botnet. In that scenario, the botnet would be recognised as something which was standard and therefore not anomalous. So you effectively would have trained your anomaly detection system not to recognise a known botnet attack. As we've discussed, within this architecture, there's a number of devices and algorithms that will try and determine if an attack is underway. Now, those can be successful, but only to a certain extent. I mean, it has been documented that 40% of SecOps teams receive around 5,000 alerts per day. Now, this is a lot of triaging that SOC teams will have to do. Also, from an anomaly detection perspective, we may have trained the models on top of already an infrastructure which already has got an attack underway as well. So there are a couple of issues with this, as you could see. So the understanding if an attack is actually happening from a kind of SOC team perspective requires a lot of knowledge. They have to understand the architecture of the infrastructure. They have to understand how software is being used by users. They have to know who their users are to understand if there are actually true positive alerts being triggered by the platforms that are trying to determine if an attack is underway. And with that significant amount of knowledge that's required, it can be very difficult for a SOC team to cope with the magnitude of the alerts that are actually occurring and the amount of knowledge is required to remediate any actual specific attacks that are occurring, and also to identify any false positives. So alerts can actually happen because the anomaly detection system has picked up something which it thinks is actually an attack, but it's not. So what we want to do is to minimize the amount of time that the SOC team is actually having to look at false positives, so they can actually concentrate on the work and the task at hand. So within the next series of papers that we're going to produce, we're going to look at what the missing link is. And we do actually have a suggestion to be able to address the problem that we're actually facing in today's security environments. And what we're actually suggesting is that we actually make the application providers responsible for the triaging of alerts and also for building some of the anomaly detection models for the organizations that are actually purchasing the services of these applications. So there's a lot more to come. I hope you've enjoyed the paper, and I will see you next time.